Weather is one of the most uh, important topics that we discuss when we fly aeroplanes because it is, I can say, the determining factor that impacts aviation safety. Welcome once again, guys, on my other presentation. After a very long time, due to all the busy schedules I've been into, I was unable to make any further videos as tutorials and to share with you, as I always do, my experiences that I learn whenever I am operating a flight. So today's topic is about weather and how we take decisions to avoid going into severe weather, and also to keep safety as our utmost priority as pilots. Before we continue, just bear in mind that many other presentations have been posted on this same platform, which I encourage you to look at because everybody has shared their own ideas on how decision making takes place when we are flying in seasons that are a bit unfavorable for flight operations. And there are many things that we do in order to prevent ourselves from entering into any funny situations or any embarrassments, or rather any serious situations that questions our operations of an aircraft. So let's start by discussing about what we do, or in general what has to be done when weather is a factor of the day to consider just before you start your flight. So the first thing that we do, or I have always done on my part, is if I know that the season has a significant weather activity, I will always call the departure aerodrome first in the morning from my base, my accommodation. I will also call the destination aerodrome, and I'm also going to keep myself informed with applications like Windy and others that are available on either Android devices or Apple devices. This just gives us general picture of what we will be encountering, or what we should be encountering when we actually go airborne. Bearing in mind that weather is dynamic, it changes every now and then, so we just get an average of what we expect when we get airborne and take our flight. When we reach the airport, it is a good practice, which is what I do, to see around me, scan around my surroundings. It gives me an idea on which runway should be used, or is in use rather, and which side looks good and clear, which side doesn't look good and clear, what is the winds like, and every single thing that I can factor in at that moment, I will take it into account, and also keep myself updated as I progress through the pre-flight and the communications I have with the controllers, and also finally once we start the taxiing and the departure of the aircraft. So it's very important to have a general picture by getting information from every resource possible that is available around you or with you when you start making decisions on what to do. Now we are in the aircraft, and once again, before we do our engine start, we've done our pre-flight, we've done a briefing. It is wise, what I normally do, to call the controllers again at both a destination and departure, and all I ask them is to give me their own observations on how it looks like outside, because they are sitting a bit higher up, so they can see in an unobstructed manner on what the weather is on the departure routing of the particular runway at our departure aerodrome, and also at destination aerodrome. The controller can give us an idea on how it looks like on the airport, around the airport surroundings. on the approach sectors of a particular runway that is in use, and also on the approach sector of any other runway or the opposite runway that is available. This just gives us a general picture of what we could be expecting as we are heading towards our destination. And that's when plans start to form and options are listed in the head and discussed by the pilots to be wary and consider anything that comes out of the ordinary. Alright, that's good. So we continue. Now, during taxi, after we've been given taxi clearance, the most important device, one of the most important device, but in this case also the most important device, system rather, which has to be on, is your weather radar. On the Dash 8 Q400 aircraft that I have been operating, I have come to be comfortable with a weather radar tilt of between 4.5 to 5.3 degrees, somewhere around there, while I'm taxiing. And that gives me a good picture on what is happening around me. From the ground, I can see above me to pick up all the paintings, if I can put it that way, that may affect my departure routing. And those paintings are actually the returns of the thunderstorms or any heavy weather that is around the airfield at that time. Now, there are many scenarios, but I'm just going to discuss one, and then I'm going to give you some time to think about it, because it's all to do with decision making. So decision making, as I said, starts early. The moment you wake up on a particular day, in a particular season of weather, wherever you're operating, you are already equipping yourself, arming yourself with the necessary tools in your brain, mentally, as they say that we always fly the route mentally before we actually take the aircraft airborne. So it's a very important preparation that you must always remember. So let's say, for example, on a particular day at a particular airport, runways 09er and 27 is available, or is only runway. And for example, in our case, in this example, if I can just get a little laser pointer, the southern side is where the apron is. Okay, this is where the apron is. So from the apron, you'll be taxiing your aircraft outwards, and then you're going to be facing towards the east like this. All right, so you're heading this way. Now, as you are heading this way, you know your SID tells you that you're going to depart runway 27, okay, and you're going to take off, and then you're going to make a right-hand turn towards your first fix, or waypoint rather, waypoint, RNAV waypoint, as per the SID. So you know, this is just one example, as I said, I'm giving you. You know that you're going to be heading easterly after departure in the westerly direction. Okay, so now let's say, for example, in the easterly direction you have weather. So these red designs that you see here, I'm depicting them as heavy thunderstorms that are right just a couple of miles from the threshold runway 27, but quite far, but they could impact your departure routing. And your departure routing, if you had to follow it, looks something like this. So you can see you're going to depart out of 27, make a right hand turn, and then follow the SID. And then if you now reach, let's say, for example, rather you reach this point here, that's where you have to make a turn. And this turn, if you take it in these conditions, you are likely to interfere or end up into this weather system here. Okay, as you can see where my laser pointer is pointing. So the question now you ask as you are taxiing out, you are discussing this with your colleague, you're asking yourself, which way am I actually going to go? And then you start forming some plans. Should I really follow the SID, or is there another way I can use so that I keep myself away from harm's way? Now, I want you to pause the video and just think what you would do if you were in this situation. This is one of the many examples we can give, but because of time and the volume of presentations, we cannot just continue giving so many examples. Others is just about common sense and thinking, and experience is what dictates how decisions are made. So pause the video, think of what you would do if you were in this situation. Okay, so you might have thought of many things. Now I'm just going to tell you what one of the things I would do. If you planned on doing any maneuver which keeps you out of harm's way and safety is your priority, that's all good and well. Okay, that's what we are looking for here. What I would do, one of the things I would do, is that instead of me following the SID, I would request the controller that I have seen there is weather along my path in front of the SID, so I would like to request a non-standard left-hand turn after departure. So if I do that, it will give me this sort of track, and you can see that this will keep me out of harm's way. So this is one of the examples of a decision that I would take. All right, and I'm pretty sure the controllers should be accommodating, because I know that I am the final authority as a captain, and this is what I would require if I have to keep myself away from harm's way. Another couple of examples we can give in terms of decision making. Somebody would say, okay, we'll continue with the SID, but when we reach, for example, this point here where we start turning something like downwind, we can extend this leg all the way and then circumnavigate the thunderstorms and then pick up our departure course. Pretty possible. Also, it depends on what sort of scenarios or weather is present on that end of the routing. Okay, another person would say that, okay, we're going to go straight ahead, make some orbits, climbing orbits until we're at a safe level, and then we pick up our departure course. So many things are possible. And one thing you should remember, that in such situations, in weather situations, fuel is your main lifeline. You need to decide exactly how much fuel you'll be comfortable with. Okay, because it's not only the fuel from taxiing or starting up, it's also congestions on the runway. You might be stopping for a long time. That is also burning your fuel, and then you're going to be departing, you'll be circumnavigating through weather, that's another fuel. So if you take fuel, maybe let's say the operation guys give you, because they want to conserve fuel simply for economic reasons, but for you the main priority is safety. So you don't have to exaggerate the tankering of your fuel, or the uplift of a fuel rather, but you must take enough that you know that with this fuel I will be able to maneuver and fly the aircraft within the parameters of safety. Alright, so this is a scenario that I would give, and then it's good for you to also discuss and with your colleagues and your workmates on many other scenarios that you may get. And it's interesting on how different people design differently, as long as safety does not come under question. Alright, now let's say we are on departure. Okay, so on departure, it's very important that you look straight ahead of you. Okay, if you go back and you look at that runway I gave you, 09 and 27. Okay, so the runway 27 was a departure runway. Let's say I put forward before you a simple question. Just as you departed, or rather, when you line up runway 27 and you look at your weather radar, that's very important. Before you throttle down or power up the aircraft for the takeoff roll, take a moment to let the weather radar scan the area ahead of you. Okay, to scan the area ahead of you, so you can actually decide, as I do my rotation and I reach my minimum altitude to make a turn, would I be going straight into weather, or I'll be clear? If you see that the weather is right on the threshold, so let me give you some diagrams in the following presentation just to show you what I'm trying to say. Right, so I'm going to use a Microsoft Word presentation here, rather the software, and to show you what I'm trying to say. So very simple schematics that I can give you just for your knowledge. Let's say, for example, your runway is 27 and you are departing in that direction, okay, like this. Now on your weather radar screen you can see that somewhere just next to the threshold, or just after the clear, if there's any, or just a couple of miles out, runway 09, you have weather, okay. And when you depart, you are seeing that you are going to be going into the weather, okay, in this sort of fashion after you rotate. So I would like to ask you a question. How would you decide what to do in this situation? You right now are on runway 27, okay, so your aircraft is exactly on the threshold here. All right, let's see where your aircraft is. All right, and you've lined up and you want to start your takeoff roll, and then you see on your weather radar screen that as soon as we rotate, just after, let's say, 200 or 300 feet, if not 500, somewhere around there, you will be ending up in a thunderstorm. Okay, so what is your decision on this? Pause the video again and just think, what would you do? Would you definitely shoot yourself into this thunderstorm, or are there other options? Okay, so I'd like to pause yourself and then pause the video rather, and then just decide what you do. Think about it, and I'll come back to you in a few minutes. Okay, so hoping that you have made some decisions. Again, as I said, that everybody will have their own decisions, but safety comes first. Okay, a safe decision is what you get paid for, and situational awareness is another thing you get paid for, and problem solving is also another thing you get paid for. Very important for you to know as pilots. So if you had a situation where you would end up into this sort of situation, rather, I would actually disregard using runway 27, okay, and I would actually ask the controller to allow me to use runway 09. Okay, so I'll taxi all the way my aircraft, I'll taxi it all the way to runway 09, and then I'll backtrack 09. All right, all the way. This could chew up a bit of fuel, so if you remember what I told you about fuel issues, take enough fuel when there is weather, because it's not only the weather that may impact you, but there are other factors as well, like congestion of the threshold. You have to wait for a very long time for departing and arriving traffics, okay. That will compromise your fuel that you may need to avoid serious weather en route, and to make good decisions, which is to do with safety. So in this case, what I would do, I would come to runway 09 and depart in this direction when I see that this side the weather is all good. Okay, this is what I would do. Now another situation I can give you on the same runway. Let's say, for example, we remove all this. Now we are done with this, that, and let's say that now we are again on runway 27, okay, and let's say we have lined up good to depart, but this time the weather is slightly further out, okay, slightly further out, so that maybe when you depart, not maybe but likely when you depart, you can still reach a height of a minimum height above the ground, okay, minimum height above the ground of, let's say, 500 to 1000 feet. Some companies are using 500 feet, some are using 1000 feet. So above the ground you have minimum height. But if you continue on this departure routing, then again you risk ending up into the weather. Okay, so what did you do now? Okay, that's the main thing, because you can only start turns when you are above your minimum height above the ground, radio altitude height, before you can commence a left or right turn. So what would you do? Would you actually follow the SID, which tells you to go to a certain point here, for example, like that? Okay, so you do this into weather and you're climbing, and you do like that. Or is there another way to keep you away from this weather? Obviously there is. You may request for an early right-hand turn rather, or an early left-hand turn. Another situation you might get that maybe, for example, your SID tells you to turn right, but on the right, let's say for example, you still have some funny situations here. But if you look at on the left, okay, if you look on the left, you might be very clear on this side. So there are all sorts of decisions to be considered. You may request a non-standard left-hand turn. So instead of going straight into this weather, you might request for an early turn, left or right, depending on how it looks like, all right, and then you proceed on your destination, or on your routing rather. So there are many ways, many things that you can do. Some situations are such that you are really in the corner. You can't do much about it. So it's a matter of just deciding what is alternative. Okay, what are my aircraft capabilities? If I have to go into a cell, okay, what am I meant to do? All right, for example, deliberately or intentionally you don't want to do that, okay, but there are ways to avoid, and most of the time you do find that there is one way or the other where you can avoid. Instead of deciding out of impulsiveness and just say, let me just do this, I don't care, you don't do that in aviation. Okay, you got to relax, calm down, ask what you want to do, and always be safe. If somebody does something that is a bit weird, that's them. You don't have to copy them. Okay, in aviation, copying never helps. All you end up is into disasters. So let's get back to our presentations on the slides, and then I can tell you more on what to do. So here I've given two examples. Okay, is either you backtrack on a different runway and depart if you see the weather is ahead of you, is right above the threshold of the opposite runway, or if the weather is slightly ahead of you on the departure routing, but you know that if I reach my minimum altitude in the climb and I continue on that routing as published, I will end up into weather, request for an early turn, right to left, which one of them is a standard one is a non-standard one. If you know that on the standard one you'll have weather. I hope that is making sense. So now we are going to go back to our presentations on the PowerPoint, and let's see what is there for us to talk about. Okay, so we were here, and I've given you an example on the turns that you can request for depending on your assessment of the weather on your departure routing. So now the next thing that we do is again the same thing, request non-standard departure if unable to comply with the SID, turn left instead of right, or vice versa. I also said that in the picture that I showed you, rather diagram that I sketched and I showed you. And request opposite runway, I also showed you that one as well on the same schematic, on the sketch that we drew. And another one, let's say, which is what I said, you can even make orbit climbs above the aerodrome until you pick up a departure track. I showed you that on the example when I was talking about the taxiing, and then you see a weather on the opposite side to where you are about to depart, and you also saw what I meant by that. You can always go backwards and revise on what I meant. Other features, other decisions rather to take care to consider rather, is delay departure. So if you know that it's a tight situation, delay your departure. Weather is dynamic, it's going to come. If it's a very strong rain, thunderstorm, it will come 45 minutes to an hour, could be maximum. Sometimes it goes to 1 hour and 30 minutes, but rather delay than to end up into a funny situation. Worst comes for worse, you cancel the departure completely. But before you do this, you've got to be very, very careful on how you are approaching your decisions in this case, because not many people will be happy if you do that. I'm just going to remove my recording toolbar here. I'm using Active Presenter. By the way, I just wanted to remind all of you who follow my presentations, they're not very fancy. I just want to deliver the information without putting in too much that maybe is not needed for my presentations. So I'm just going to make it very simple. As long as I can deliver the message the little I can, I'll be very happy. And if you are learning anything from it, it's also a plus point for me. Right, my last message on this slide, which will be the same message on some other slides: never ever go into severe weather. As much as possible, please avoid it. Please avoid it. Much better to avoid than to prove yourselves that you are daredevils and you can fly into nature, and nature is very unforgiving at times. It doesn't care who it is. All right, so it's better to keep your reputation on the safer side by being as a safe pilot. Good. Now we've talked of lots of things. Now we're going to talk of en route. So en route, what do you do? When I'm cruising 25,000 feet or 23, whatever it is, I like tilting the weather radar to around 1.5 to 1.8 degrees. This works well for me, but others have their own preferences. It works well for me because I'm able to see or distinguish between the individual cells or the rain or whatever it may be with my settings of these numbers. Okay, so very important, the little knob you have on your center pedestal on the aft where the weather panel is, where the radar panel is rather, is a very important tool that you must get used to. And now, as you fly more into weathery conditions, you will come to know that what you see at one instant may not be the same as when you approach that system. Alright, some are well defined thunderstorms. They are actually what you see from far away. They are like standalone and they are there. But sometimes I've noted that you have, let's say, a bunch of clouds ahead of you. You know there are thunderstorms somewhere, but sometimes it looks like it's only one whole thunderstorm. When you approach a bit closer, you can now start to separate and say, no, I can see 2 or 3 of them here. Alright, so your weather radar, apparently turboprop weather radars aren't that great most of the time, as much as the jets are, but still more. Some Q400s I've been flying recently, some of them have given me real-time picture of what I see outside to what I see inside, and this really helps you, especially at night. Especially at night, it really helps you. In the daytime, if it's a cluster out there, you only see clouds and storms all the way, you are still able to know where the gaps are, where you can steer your aircraft through and come out the other side without going into too much of a problem, okay, too much of a turbulence. So as the literature and the texts say, 40 nautical miles is a good decision to reach a particular thunderstorm cell or cells before you decide to circumnavigate left or right. Okay, now if you put for those of us who are flying the Q400, if you put your range on the EFIS control panel, the range knob, to 80, it's going to bring you a 40 nautical mile arc on the MFD. So you wait until the painting reaches or touches that arc, means you are 40 nautical miles from that weather system, the thunderstorm cell. Then you are able to decide which way to go, left or right. They also say in literatures that we avoid a thunderstorm by 20 nautical miles laterally. Okay, we never overfly a thunderstorm. It's not very good at all. Or we never we don't, if possible, we must never go into one. All right, and if you go into one, there are certain procedures that are laid out, but you must always avoid flying into these machines that are made by, I can say made by God, but they are, as we say, nature driven, and you do not want to enter any one of those. Okay, so 20 nautical miles laterally is a good separation. And also squall lines, these ones here, squall lines are, you know what they are, most of you do know what they are, all of you. They are lines of thunderstorm, like soldiers standing right in front of you, telling you what to do and what not to do. Okay, so it's very important that you know these things. Just getting a battery low message here. I'm going to close this one, and just a second. So very important, sorry about that little interruption. I just had to plug in my laptop. All right, So very important scroll lines, and these you sometimes people avoid them by hundreds of miles, 80 to 100 miles most of the time. I've done that actually. I have my largest deviation I've ever had is around 91 to 95 miles of scroll lines. Okay, so some of these things are not very good to meet, but if you happen to be there, be mentally prepared. Okay, so I don't think I've missed much here. I think I have talked about quite a bit of detail here, but if I have missed, it's important that you actually comment on in the comments if you can. It's always valued. Some people have their own comments, and all the comments are very valuable to me. This point here that I've just brought up on the slide, request DTO to a waypoint, direct to a waypoint, is one of the decisions you can even take. So let me show you what I mean by DTO, and DTO mean direct to, but let's give ourselves a scenario. So we're going to go back on our Microsoft template and make some sketches. So here we have 3 waypoints. Okay, 3 waypoints. So let's say, for example, this is A, rather capital A. All right, it's capital A, and this one here, if I can put it as waypoint B, all right, waypoint B, and this one here down here we say is waypoint C. All right, so now let's say our routing, simple example, is going to go from A to B to C. That's our normal routing. But now if you see maybe around waypoint B, there is some sort of funny weather situations here. Okay, so is all this part here is all packed, for example. All right, so what do? Well, it's very possible, most of the time it has been possible, that you request a direct routing from waypoint A to waypoint C directly. So if anything, we can say to the tower that at waypoint B there is some weather situations, so we'd like to request going from A direct to C, like this. All right, so this is called DTO. All right, so in the FMS you do DTO, and I've explained about DTOs and VTOs in other videos, depending on whether you are straight and level flight or you're descending. It's very important you go and see also those, because sometimes the descent, if you do DTO direct to C, you may make the aircraft dive, but this is a subject of another video which I've already made. You can go and review that one. If any of you don't understand what I'm trying to say here, you can definitely make a comment and I will separately explain to you what I mean. It's not a problem at all. Alright, so this is what I mean by DTO. So you don't always have to follow a routing blindly. If you can bypass a particular waypoint because there is congestion in terms of weather rather, and you just cannot go there, then you are free to go from A to C, for example in this case. Alright, so that's one example. Let's go back and discuss more. Okay, so all these points have been covered, and my last point here, which I have just brought up, is a very, very important note. Never ever attempt to pass in between two storms. Okay, it is dangerous because you never know those storms are closing in, and by the time you are in between them, they will sandwich you. So never ever attempt to pass in between two storms as much as possible. Another literature on weather avoidance says that you must always avoid or circumnavigate a thunderstorm cell into wind. So wherever the wind is blowing from, you avoid it into wind. But most of the time that may not be possible, because maybe into wind will take you very far out into other weather that is outside. So sometimes it is also a good idea to avoid it downwind by a larger distance compared to into wind. These things just are decided on that moment, as long as I keep saying safety is not compromised. Okay, we don't always follow things blindly. We also have to use our common knowledge, and based on what we are having in real time, instead of following what maybe the books say sometimes. Okay, although books are extremely important, but sometimes situation dictates how you decide, and decision making has to be flexible. You cannot have a rigid decision making. You cannot just stick to one decision. yeah, you will come to know that in times of weather, your decisions are being changed maybe 2 or 3 times. Okay, because what you thought of at first isn't what it's looking like as you progress with the flight. So your FMS entries may become different again, and all sorts of things will be happening. So you've got to be very adaptable to these situations. That is what makes a competent pilot. Okay. Having said that, we continue with our presentation on weather avoidance. So let's say now we are coming in for the landing, approach and landing. Again, my tilt in approach and landing phase is around 2.3 to 3 degrees. So what I'm interested in is to see the weather above me, not what is below me, because I'm going to be hit from something above me when I'm coming in on that 3-degree glide path for the landing, or for the approach phase rather. Okay, if you see there is weather, well, delay your approach, you hold. If no improvement is seen after a long time, fuel seems to be compromised, okay, you divert. Okay, you go to another airfield and you wait. Order yourself a cup of coffee, disembark your passengers, and say we're going to wait until the weather destination which you are going to improves. No harm in that. Better be safe than to force matters and end up into headlines. You don't want to do that. So now I'm going to show you an example again on a sketch. So a typical RNAV approach has some fixes. We call them the initial fix, initial approach fix, and the final approach fix. So in my sketch here, the ones I'm circling here for now in green are what you call the initial approach fixes. Okay, so these are initial approach fixes. Then the perpendicular line that passes through the center line of the approach intersects at what you call the initial fix. So this part here, which I'm shading in a light gray, is initial fix. Okay, and then the one which comes off initial fix is called the final approach fix, this one here. All right, so just remember that this one, these ones here, this one, excuse me, so this one, these ones in green here, in green, those are initial approach fixes. This one here is initial fix, as a final approach fix. Now let's give you a scenario. So let me just remove maybe the circling, so at least you know what I'm trying to achieve here. So let's say, for example, you are coming in from the north. Let's say east is this side. Okay, east is on your right side. Okay, west is on your, just to make matters simple, west is on your left side. So obviously the north is above the page, and obviously south will be below the page. Now you are coming in from the north, somewhere north, northwest, something like this, and your first waypoint on this approach should be this initial approach fix, this initial approach fix here. You've got to you start your approach from this fix. Now let's say, for argument's sake, that on this approach fix you have weather, okay, on this one. All right, now what do? So you're quite far out. Don't be misled by the scale of the drawing. You're quite far out, and you are in this situation. So what would you do? Would you continue on this routing, or are there other things you could do? Well, you can definitely decide. You are free to go. Let's say, for example, you can request to go to this initial fix here, somewhere there. You can even go there and shoot your approach. Okay, if you are very far out, you may also maybe try and go to the final approach fix, somewhere there. Okay, and then also shoot your approach. It's quite possible. All right, so many things can be done depending on where you are coming from. You need to know where you're coming from. Let's say if you are coming from this angle here, for example. All right, if you're coming from this angle here, all right, let's say you have to go there and come like this, and here there is weather. Well, maybe you don't have to even go that far. You can go straight to the initial fix, which is this point here. Okay, so there are many ways of circumnavigating weather depending on where it is. Sometimes weather can be, let's say, at the initial fix itself. What are you going to do? The only option there maybe would be to go to the final approach fix. Alright, it's quite possible. And if the final approach fix has got weather, now we're in a situation where we don't want to proceed with this runway, because this is the only fix that you've got to start your approach from, your 3 degrees descent. Alright, so if weather is on the final approach fix, let's say here somewhere, then we have a situation where we either pick up a hold at one of the initial approach fixes, or initial fix rather, or we ask for the opposite runway. If we can't, depending on winds or whatever, then we hold for a while until let's see the improvement of this weather. Maybe 30 minutes, maybe 45 minutes, we can hold on one of these fixes before we decide to divert. Okay, so in weather conditions, diversion and go arounds should be right in front of your forehead, because that's what you should be expecting. You don't want to do those things for reasons of commercial reasons, but I mean commercial reasons are not your priority as much as safety is. Okay, so this is what I meant on the slide when I say you can request a hold, you can go to another fix which is free from weather and the like. These are just some of the decision making techniques that I'm offering you, because I've done these, I've met them in real time, and it is my obligation to let you know what I have been doing, and thank God until now everything has been working out in my favor. Right, let's get back to our slides. Right, so this has been discussed, and now the next thing, as I said, alternative runway can be also requested if you have weather on the center line of the runway you're coming in for the landing. This is what I gave an example. Request another initial approach fix or initial fix, or direct to the final approach fix, as I showed you. Often you are coming in and then you just want to, you've lined up on the center line and there's a lot of rain. I've experienced this recently, a lot of rain, you can't see anything outside aboard the landing because you can't see where you're going. So aboard the landing, do your ground maneuver and then you turn to the ground routing if possible, or you do a non-standard routing where you are free from terrain and you're at a safe altitude where you can orbit and wait for the weather to improve before you attempt another approach and landing. Bearing in mind that legally you're only allowed to make 2 go rounds before you decide to divert. Go round is very important. You follow the procedure, but as I keep saying, do not follow any procedure blindly, and which puts you into a safety compromising situation. If you read this paragraph correctly, follow procedure if no weather on go on track and holding fix, otherwise plan for non-standard route, terrain permitting. Keep this in mind. I'm going to show you a real-time scenario that I faced using the weather radar on my aircraft, so please keep this I can say 6th bullet point in mind, and I'm going to come back to it and explain to you in a pictorial form. Okay, then often if you've waited for long and you know you cannot land, or you know that in this case I cannot land at all, even though if I'm going to hold and waste my fuel, this weather doesn't seem to improve in any good time, you divert and you go and wait at your alternate. Alright, and once again, as I keep saying, never go into severe weather. Good, discussed quite a bit there, and a couple of important CRM points are important here. PIREPs, known as pilot reports, are very useful. If somebody has been coming out of that airport that you are going into where there is significant weather activity, they can tell you what is happening around the vicinity of that airport, so it can give you time to plan. It has happened to me quite a few times where decent airmen, I can call them, who know what airmanship is, have actually come forward and told me, well, the thunderstorm is moving this way and that way, so I had to orbit, I had to hold until things improved. I had to talk to the controllers to get their observations. So a lot of things happen when there is weather around you, and you've got to be prepared. As I said, be flexible to change depending on the situation. Your decision making should be flexible. You can decide, as I just said a while ago, you can decide something now and it will change at an instant when you are nearing your destination. So use your resources. CRM, crew resource management. CRM, user resources. Use your first officer, use the other pilots in the vicinity, use your controllers, and use your own judgment as well. So talking to each other is a very, very important airmanship sort of thing that has to be there. Sadly, some don't care about where others are going, but as an airman, you are not only responsible for your aircraft and your passengers. If you can help and give a hand to others around you, that is what you call a true airman, a true pilot. Alright, nice. We continue discussing. Now I'm just going to show you some photos to show you how it looks like from the cockpit view on some of these weather systems I've met. You can see that they don't look that friendly at all. Some of them you don't want to go into. This one here, I can tell you, is a complete no-go. It is a thunderstorm. I passed slightly next to it, but I was quite far actually. I wasn't even interfering with it, but this is a no-go, so very important. Alright, and now we come to the weather radar depiction, what the weather radar shows us. So most of you have read about this, and of course you know. I'm just going to give you a quick reminder on what each color means. You can see the table right on the top right hand corner here, this part here. You can see the table: green, yellow, red, magenta, and the descriptions, and most of you know this. So basically, if you look at green, there it is. That's heavy rain, heavy rain. It's just rain, literally. It's not like that's serious, but it's quite a downpour. But you can go through it if you have to. It won't harm you. It will be a bit uncomfortable, a bit bumpy, but it's pretty much heavy sort of rain. Yellow, this one is significant heavy rain, I can put it that way. This one you do feel the impact, okay? And red is something you just don't want to go into, literally. You've got ice pellets maybe there. It's not a very nice, comfortable environment to fly into. I wouldn't fly into red unless the situation was so dire that I needed it, but I don't think you need to fly into red at all. Okay, now looking at the depiction of the weather radar, the other one is called magenta here. The magenta is very serious. Magenta is just like entering a butcher's machine. It is extremely dangerous, heavy turbulence, and prone to structural failure. Never ever go into magenta, never. Okay, now I want you to observe this boundary of this picture here. Okay, so if you see a boundary like this, all right, an outline which is very loose, not well defined, all right, something like this is not a thunderstorm. It's not a storm. It's just a cloud, a very, very moisture laden rain cloud that you are going through, okay, which you will come out eventually. Okay, so if you see a depiction like this where it's loose and broken, all right, this means it's just a cloud, a sort of threat as such. Avoid if you can, but flying through it won't give you that much of a problem. You'll be beaten just by heavy rain. Okay, then you see something like this. Okay, now here you can clearly see the edges of this picture. Okay, they are well defined. It's like a map of a country, or if you can put it that way. You can see all this. This is a thunderstorm. All these on this weather radar which I've seen, it was my flight actually. It's not a very. I remember going through this gap here, completely through this gap. I had no other option, even though I had stated that you always you don't go through two thunderstorms, you don't go in between them. The wind was coming from the left, as you can see, but I had no choice. When I came here, I just closed in. It was quite a bit bumpy. I went through here, and then my destination was somewhere ahead of me. Okay, so this area was quite packed with all sorts of rubbish, I can say, that you can be given it. Okay, so if you see this sort of picture where the edges are well defined, okay, they're not loose as such, and you see all the colors lined up, green, yellow, red, magenta in one, that's a thunderstorm, and that is something you want to avoid at any cost. Okay, good, we continue. So here is another depiction of the weather radar. I've been through some of these. You see this is 80 miles here. You can see it's an 80-mile arc, so I set my weather radar zoom knob at 160, so it gives you 80. All right, and it shows me what I'm seeing further out. Just a point to make, very important point to make, that when you're flying into weather, it's better that both of you, the pilot and the co-pilot, have different weather radar ranges. One is seeing something a bit closer and another one has something a bit further out. So the pilot flying can see what he or she is flying that is near him or her, and also from the other person, he or she can see further out. Doesn't matter who keeps what range, as long as the range are the same, because you need to plan ahead as well. If you keep one range and you see things are looking beautiful, you may enter an unexpected territory because you didn't plan for it when it comes to you, and you have little room to avoid. All right, so it's very important you understand that. All right, so this was pretty much avoidable. This is another approach I was doing into an airport. Okay, I was on the base leg from initial approach fix, or the initial fix here. Let me just use my laser pointer because the cursor isn't being shown most of the time. So initial approach fix was here, initial fix was there, and that's the final approach fix was here, and the weather was to the southern side of this airfield, and you can see a thunderstorm I saw, and as I told you, the edges are well defined. If it's at night, you can't see, you can only see lightning flashes. You can clearly tell it's a no-go zone. Okay, so just to show you some weather radar depictions here. Here's another, the same one rather, it's the same one. This is when I was turning finals. I was turning finals on that particular runway, and here's the whole situation here. So now I'll ask you a question on this one. You remember, this is the first of the go-round idea that we discussed a while ago. I did tell you, if you remember, that keep that point in your mind, because I'm going to come to it to give you a real life example on whether you should be following blindly a procedure or not. So let's say, for example, my go-around routing for this particular runway was to make a left-hand turn and come back and land onto this runway. Now, would you do that? That's my question. Seeing that on the left side of the track, meaning this is the southern side, you are seeing this sort of picture, would you actually go there? Or would you request for a non-standard right-hand turn where the weather was more civilized? What would you decide? And if you have said that you do the latter, I'm with you on that one. Okay, because going on the left and ending up into the weather and you put yourself in a corner is not a very good airmanship and a good decision-making skill. Okay, good, we continue. Here's again, I told you about this. This is rain clouds, dense rain clouds, and you can clearly see them by the not very well defined edges. Once again, my pointer, these edges are not very well defined, as you can see. All right, and this is just light to moderate rain, so you do get hit a bit. You can feel the rain hitting your windscreen, hitting your aircraft roof and the like, but nothing that serious. You don't want to be in this for long. This was actually on a final approach to a runway. It was just rain, so there was nothing above me like a threat of a microburst or a thunderstorm. But I'll tell you that sort of thing which was present in the forthcoming slides. Right. Here we departed out of an aerodrome, and it was again heavy rain. I could see this again, these edges. Very important that you know that these edges were not very well defined again. So it was quite a cloud above me, very moisture laden cloud. Okay, and the more I was going further and the more the nose was squashing into the water, it was giving me a picture of this sort. Okay, nothing big, but still a bit bumpy, but I went through it and came out the other side. It was all packed all around that area that day, I remember. Not very comfortable for approximately 25-30 miles out. Alright, very simple little clouds, well, not little rather, quite big, but because of the range is very high, that's why they look little. Here we go, about the go-around. I would like you to focus on this. This is what I was talking to you about. the second scenario for go-around route, go-around procedure. For this particular runway at this particular airport, the go-around procedure says after you go around, you make a right-hand turn and you go to this place called Unkog. Okay, it's a waypoint. It's one of the initial approach fixes, IAF. If you remember from the Microsoft diagram I was drawing, this Sankey is the initial fix, and this Delta Alpha 602 is called the final approach fix. Okay, now if I had to make a go around here, let's say for example another aircraft in front of me burst a tire, or there was some sort of runway issues, or there was I don't know, I had to abort my landing because of tower instructions or unstable approach, or you name it. Okay, would I, or would you rather, follow this go-on routing, knowing that Unkog is your fix where you've got to pick up a hold? You can see it's white there, there's a hold arm there. Would you go here? That's my question. Would you go there? If your answer is no, I would really support you on that one, because I don't think I would. Okay, I would request for a non-standard left-hand pattern to hold at a waypoint which is somewhere, which could be somewhere here, for example, this point here. Okay, there. It should be there. Okay, I would be holding here somewhere, which is another point opposite to Unkog. Okay, but also 6 miles out from Sankey. So I would be holding here. I'll be holding in any area, because in this area it's clean. You can see there's nothing here. All the storms and all the bad weather was here, so you'd not follow the go-around routing. Okay, this is called decision making. Don't be rigid. Okay, you have to be safe all the time. So very important that you understand what I'm trying to say there. Okay, so this is basically the Unkog waypoint where you had to hold, and you wouldn't in this situation. Okay, you would hold in this area here where you see there is actually clean weather. Okay, and here's again an approach, same runway, a different angle, different day. Just wanted to show you how the difference between the outlines, the boundaries of this rain cloud and the thunderstorms which are on this area here. I think the cursor wouldn't show, laser pointer. So this is all the rain cloud which was on this segment, and all this is the thunderstorms. As you can clearly see, these are no-goes, alright, but these here, you can fly into them, a bit uncomfortable at times, but no choice sometimes. This is not a threat as well, so you can definitely dig into this one and go ahead with your flight. Okay, again, decision making and being safe is very important. Right, so that's what I was trying to point out there. And same picture. Okay, a bit blurred here. Right, quite a few cells. This one was quite tough for us actually. We did depart, and I remember we went through this gap because there was no way out of this. We had a puzzle to solve, so we took off, and I remember going somewhere like this, and then I went something here, I went there, and then I picked up my departure course somewhere here. So I had to avoid all this mess which I had ahead of me. That's why fuel is the most important thing when you are flying in these situations. Honestly, it's not a very good feeling if you know that your fuel isn't enough to do these circumnavigations, they call it. Yeah. Okay, here's another scenario. Now this is a very important one that I faced just recently, and I'd like to talk about this one. We were coming onto this runway here. If you can see laser point, we were coming straight as our initial routing. The magenta you see was modified after we took a decision due to the weather here. Now from far away, when I saw this weather, it was standing right above the final approach fix of the runway in use. Okay, it was somewhere here. This was a program of the opposite runway, but this waypoint here is the final approach fix rather of this runway, which is, let's say, facing towards top of the slide. Okay, so I'm coming from here. When I noticed that there is weather on the final approach fix and it's a thunderstorm, which I could see from outside and I can even tell from the weather radar, all I asked the controller is that I'm going to pick up an orbit at my present position because I cannot go through this weather. It is impossible. Now the runway in use at that time was this runway, and I just declared that I'm not going to be able to make it because they kept that runway obviously for departures and arrivals, but I mean the moment it was a bit free, they said you can use the opposite runway. Okay, this decision was very warmly welcomed by many colleagues who heard me doing this. So I said, no, I'm not going to go here. I'm going to go to the opposite runway, okay, and land, because I saw the weather this side was clear. And that when we lined up on that runway, on the opposite runway, you could actually see how the weather was looking like on the end we were coming from. You can see all this weather here. This is where we decided to deviate, and then we went obviously around this weather. So let me just bring my laser pointer again here. We came here, we never followed this magenta, we went around this weather and picked up our base leg ahead of us for the opposite runway. Okay, that's very important. And this is what I wanted to tell you, is to fly safe all the time. So always when you are deciding to avoid weather, make sure that you avoid weather with the safest course of action. CRM is very important. Always listen to your colleague. They may have ideas you haven't thought of. It has happened to me many times, okay? And I said, I didn't think of that. So always ask, do you have any other ideas? And they will share with you ideas, okay? Don't be rigid in decision making. Always be flexible. Always be ready to change decisions at an instant, depending on what you are facing at that moment. Flying is dynamic. Weather is also dynamic. So your decisions should also be dynamic. Remember, safety is your priority. Your priority is not time pressure, commercial, no. Your priority is safety. You want to operate your aircraft in the most safest possible manner to keep yourself, your aircraft, and your passengers on the safer side. Okay, and your crew as well. So remember, always fly safe. Till the next time, guys and folks, thank you very much, and I hope this has been a bit helpful. But as I said, please visit and look at other presentations from other authors on this platform. Learn from everybody, share, and always, once again, fly safe. Ciao, and have safe and happy landings.